We are now going to narrate to you a story on jaggery making and how the research and development team at moved from a traditional cottage-based industry to a continuous technology-driven process. Historically, jaggery has been understood by consumers as a natural product, and with that value attached, it has more and more preference from the urban communities over the white refined sugar. Just to give you a little idea on the total production in the year 2010, all across India, we made something like 10 million tons of jaggery. Jaggery making is currently prominent in the states of Maharashtra, Uttar Pradesh, Tamil Nadu, Andhra Pradesh and Karnataka. So the raw material for making this particular product is sugarcane, and the essential characteristic of this particular distributed small-scale production unit is located at the sides of the farmers' fields, because obviously the advantage of transportation of cane to the production unit and the production capacity in batch mode of 8 to 10 hours per day in a season of about 120 days is something like 1 to 2 tons per day. Before we undertook this project on an intervention to develop a new innovative process, in order to understand the problems, because we had noticed about 6 to 7 years back that while the demand and consumption was almost the same or to an extent increasing, the production had been decreasing, and the primary reason for this was that the process was very labor intensive. To give you an example, 10 years ago, there was something like 900 units working in a single district of Kolhapur in Maharashtra state. But in today's time, there are only 500 to 600 units which are operational. In order to understand the problems in this sector, we undertook a survey of jaggery making units, and we surveyed something like 400 jaggery making units. What we found there was the unavailability and the reliability of labor in the season. When we wanted to produce, the labor was not available. So therefore, we did a survey and found out that there is a great deal of interest in a process which can be a little less drudgery driven and a lot more user friendly. Therefore, what we did was try to understand the conventional batch process. Now, let's look at the conventional process which is traditionally practiced in jaggery making units all over India. Cane is first crushed in the crusher and the juice is transferred to the heating pans. Now, these pans are typically about 12 to 13 feet diameter, very large, and are heated from the bottom with the help of the gas. The gas is burned in a furnace, and the juice is then clarified by adding various additives. In jaggery making, lime addition is a very crucial step. Lime is added to adjust the pH of the juice, typically from 4.7 to 6.4. This is to precipitate the major impurities out and make clarification easy. Furthermore, a higher pH prevents inversion of sucrose to glucose and fructose, thereby increasing the hardness and shelf life of the product. In the conventional process, lime addition is done only based on the judgment of the master craftsman, as there is no pH measurement done in this case. Whereas in our process, which is the newly developed process at I, we have completely automated the lime addition and made it operator independent. Now, while doing this, we have to have a man standing there all the time. The precipitate that is formed in this case floats over the surface. This has to then be removed continuously, and that is how clarification takes place. So this is a very high labor intensive process, whereas in our process at high temperature, the flocculants that are added are different, because of which the precipitate has a high density and it settles down, and this makes the process very easy, wherein the precipitate settles down and a clarified juice comes out from the top. This particular process doesn't need any labor at all, and if it is controlled in a precise way, that is how it would be. In a conventional process, once the juice is clarified, it is subjected to evaporation for about 2 to 2.5 hours. It is a continuous heating going on and the water vapors are coming out, and all the time the person standing there has to look at the scum that is coming out from the surface and remove it. Now during this period, he keeps on adding several additives to maintain the color, maintain the pH and so on. The juice gets almost ready for crystallization. The master craftsman who is responsible for operating this particular process as a skill has to know whether the evaporation is over and if the juice is ready for crystallization. So he performs something called as the goalie test, which is more of an art than a science, and this is an indication of how much moisture is present in the juice. So once the evaporation is over, the juice is transferred to another pan wherein it is cooled down to some extent. That is from 118 degrees centigrade to 70 to 80 degrees centigrade. During this process, the juice gets thickened further and the crystallization starts happening. There is a lot of labor required in this process to stir this thick syrup for about 15 to 20 minutes so that you get nice crystal jaggery. In our process, we are following a different way of evaporation. It is a continuous process, which means the clarified juice that comes from the clarifier goes through different pans. Now it is continuously flowing. There is no manual intervention required in this case. So as it flows from the first tank to the second tank and to the last, there is a continuous heat that is produced and provided to these pans, and water evaporation takes place. The residence time is adjusted in such a way that by the time the juice comes to the last pan, the concentration is just ready for crystallization. Now, you can see a crystallizer that we have used in this particular case, and that it is much different from the crystallizer that is used in the conventional process. We are doing continuous crystallization here. It's a screw type crystallizer wherein the hot thick syrup falls in and gets transferred from one end to the other end. And while this happens, crystallization takes place because of the turbulence that is created. And at the same time, the screw that is rotating all the time takes care of the transferring or conveying the hot syrup from one end to the other. Otherwise, it will not flow. So this particular equipment, which has a conveying screw, not just plays a role of conveying the stuff, but also ensures that it amounts to crystallization. Again, we are saving a lot of labor in this activity. Once the jaggery is ready, it is in the form of a thick paste and it is a semi-solid material which has some ability to flow. This is then filled in molds, and you can see in the conventional process that it is again done manually with a lot of labor required. It is allowed to cool down for about half an hour when solid jaggery is formed. Then demolding is done and the product is sent to the stores. In our process, we have automated this molding process as well. So we have designed a new molding machine wherein you have different molds of different sizes and the required different shapes. They are used to collect the juice coming from the crystallizer and they are moved on the belt. And again, the residence time of this mold is adjusted in such a way that by the time the demolding happens, you have the jaggery ready in solid form. The time is of the order of 25 to 30 minutes. Since this is an automated process, it is expected that we require not more than one person to actually control the entire operation. Another big advantage here is that since we have this machine taking care of the continuous process of molding and demolding, it is quite possible that we can have different sizes and shapes that are required by the markets. In a conventional process, the way the heating is done is you have the bagasse that is generated in a crusher which has about 50% moisture. Now this bagasse has to be dried. So it is transferred on a large piece of land, spread out and sun-dried. And you can look at the labor that is required for this particular activity. It is allowed to get dried for about a day or so. That means you need a large piece of land. Again, this has to be a fertile land, otherwise one can grow sugarcane on it. So we are losing that much land just for drying. Now, this bagasse when dried is collected and sent to the furnace. It doesn't just end there. You have a person sitting or standing at a furnace continuously feeding this dry bagasse to the furnace. A batch of about 2 hours, this person is standing and collecting bagasse and feeding it to the furnace all the time. It is a highly laborious, painful job and not many people are prepared to do this kind of work. Now, once this bagasse is fed to the furnace, which is a pit furnace, it is known that the efficiency of the pit furnace cannot go beyond 40 to 50%. So, the flue gas that is emitted to the surrounding, that is, which comes out of the chimney, has a temperature of the order of 400 to 500 degrees centigrade minimum. That means we are losing so much heat to the atmosphere and at the same time there are some particulate emissions happening. So overall, the heating system that is used in conventional jaggery making is less efficient and polluting. In the new process, we have an indirect heating system. The primary source of heat is bagasse itself. It is conveyed by the bell to the rotary dryer in which it is dried. Now for drying, the heating medium is the exhaust gas that comes from the burner itself. This bagasse on its way gets dried and this dry bagasse goes to the burner wherein it is burnt. Now this hot flue gas imparts heat to the thermic oil which circulates inside a burner. Thermic oil takes heat from the burning bagasse and then goes to the plant, imparts heat, especially the evaporators and of course the clarifier. Because we do this kind of indirect heating, the energy efficiency goes up to almost 70 to 75%. With such high efficiency, we save a lot of the gas.